Let's have a look at the integral calculus section from last year's end of year 2013 exam. Here's question 38. This type of question here comes up very often, nearly annually actually, something like this. And they're not too hard, a couple of marks here, but if you follow through the process here, it's difficult to go wrong. So we've got here, we're given a value that says that integral there, that definite integral, is -7. So we're going to have to use that in here somewhere. Okay, so I'm going to have to try and tease out that value there out of here somewhere. Okay, I've got to find it and tease it out. So if you look at my first line here, what I've done is, first of all, I've done two things in fact. I've taken this 3 here, see it there, and I put it out the front, so there it is there. And I've also separated out the two integrals, because we know that the integral of a minus b is the integral of a minus the integral of b. Okay, so I've taken that rule there and I've separated out. And I've done another thing with that too. You see how it's got here minus 4x, so that could be minus the integral of 4x. So I actually made that minus 4 integral x, because I can take that 4 and put it out the front. So that's what I've done there to create that situation. So that's a vital first step. Now you can see I've now got, I'm missing a negative there by the way, I've now got this one here. Okay, I've now got that one here. There it is. So I've isolated it out because I know I'm going to have to use it. So 3 times that is 3 times -7. Now what I've done over here with the integral of x from 3 to -2, I've worked it out. You can see there the integral of x is x squared on 2. Terminal's 3 -2. So I've worked it out there. The -4 is just hung out the front. You can see it just sticking in there to there to there. Okay, it just stays out the front while I work out the integral of x from 3 to -2. The integral is 5 on 2 down here. Okay, so -4 times 5 on 2 is -10. -21 take 10 is -31. So that's how I get the answer. Okay, so I'll take away those boxes so you can see it more clearly. Away all the clutter here. Sorry. Rid of that. Okay, that should be enough. So you can now see the process there. You need to get those once. Next one is just a complicated integral. And some people have not done this in the past and tried to do funny rules with these. Okay, but when you get a bracket such as that, raised to a power, squared in this case, you've got to expand it. So you can see there in that middle section here, I've expanded 2e to the power of x minus 3 squared. 2e to the power of x minus 3 squared. So it's 2e to the power of x squared. If I do that, I get 2 squared is 4, and e to the power of x squared is e to the power of 2x. Okay, so that's how I get 4e to the power of 2x there. So replay that please, a bit slower perhaps, I could have done it, but anyway, replay that to see how I get that first term here. Alright, next, the usual rule when you've got a minus b squared is you square the first term, you multiply the terms together and double it, so minus 2ab, and then you square the third term. Okay, so what I've done there to get the -12x, e to the power of x, what I've done to get that is I've multiplied 2e to the power of x and -3 together to get -6 e to the power of x, double it, you get -12 e to the power of x. Okay, so that's how we get the middle bit, and then of course the plus 9 comes from squaring -3. So that's all I've done on the first line. Oh no, actually it's not all I've done on the first line. The other thing I've done here is, as we always do with indices that are in the denominator, is bring them to the top. Okay, so I create 4x to the minus 2 to the power of -2 if the squared comes to the top. Next thing I've done is sequentially gone through bit by bit and got the integral of each part. Okay, so to get the integral there, it's 1 over the coefficient of x. That's how I get the 1/4. Raise the bracket by a power, so it goes from 5 to 6 over that same index. So that's how I get 6 there and 6 there as well. So that's the first one. These integrals are pretty easy. This one here. So it's 4 times 1 over 2, 1 over the coefficient of x. 4 over a half is 2, e to the power of 2x. The index doesn't change. Negative 12 e to the power of x, the integral is the same, negative 12 e to the power of x. Integral of 9 is 9x, so those last two there are fairly straightforward. Okay, now the last one. I might spend a bit of time on this one here, just get rid of my arrows and things. Okay, so we've got 4x minus 2 to the power of negative 2. So what we've got to do here is it's going to be, excuse me, we raise the bracket by 1, so x minus 2 to the power of negative 2 becomes negative 1, and we divide by that same power, so we get 4 over negative 1. Now of course 4 over negative 1 like that is going to be negative 4, so that's how I get that. I better answer that call, just a moment. Okay, so 4 over negative 1 is negative 4. And as I said, it becomes x minus 2 to the power of negative 1. So that's how we get that there. Right, let's get rid of the clutter once again. Okay, in the last step, you can see that here, the 4 and the 6 in the bottom, 4 6s are 24. And over here, I've taken the x minus 2 to the power of negative 1 and place it down in the denominator position. Mustn't forget our plus c. So a bit of a tricky integral, that one. It's worth 4 marks though. So if we've done our revision on how to integrate, we should be able to get that one. Okay, we've got two curves here. Negative 12 cos pi x on 3 and x squared plus 5x minus 12. And we've got the domain here 0 to 4. It says use your calculator to determine the exact value of the x coordinates of the points of intersection. Now a bit of a hint here. See how they set up the axes? There they've gone from say 20 to neg 20, and here they've gone from neg 2 to about 5 or 6. When you set that up on the calculator, make sure you set it up exactly, or no, as close as you can. So you can see here, I've set my window on the calculator, negative 2 to about 6, and negative 20 to about 20, okay? And that is pretty much, if you go back, what they've done. So it gives me a chance to see that I've actually graphed these things correctly, and you can see there's some similarities. You've got your shaded area in there and also in there. Alright, so all that remains, once you've drawn the graphs correctly, all that remains to do is find your points of intersection. Okay, you should know how to do that by now. Analyse graph, intersection left and right, and here they are. Here's our 3 points of intersection there, there, and also there. So make sure you answer the question though. It says the x coordinates. So the x coordinates are 0, 1 and 3. Okay, so place that here. 0, 1 and 3 to mark for that. Then find the exact value of the area enclosed by the two curves. Alright, now remember when we're finding area, it's the integral of the top curve minus the bottom curve. Now here we can quite clearly see in this first section here, the top curve is our quadratic, our x squared plus 5x minus 12, so that's on top. And our trig curve, our cosine wave there, is the one on the bottom. So when we're working out the first section between the two curves, it's going to be the integral of x squared plus 5x minus 12 minus the integral of the other curve. Okay, and you can see if I develop that one step further down here, the two negatives there give me that plus there. So that's the first part. That's the that will give me that first shaded area. Now you'll see on the other shaded area, okay, so that's this area here, okay, between the two curves. Here we are, that yellow area there. This time the trig curve there is on top of the quadratic curve, okay, which is the curve below. So our second calculation, you can see it here. Let's get rid of some of these squares again. Our second calculation here is the trig curve minus the quadratic. Notice how I've bracketed, and we've mentioned this a lot of times in class, notice how I've bracketed that x squared plus 5x minus 12. Alright? So there we've got our two integrals, two calculations. That's for the first area, that's for the second area. Second area, remember, is integral of 3 to 1. First one is integral of 1 to 0. Alright, now the answers from last year's examiner's notes, they go on to work all this out. Now it's pretty heavy going, as you can see, once you start integrating these things. Best to try and do it if you can. Okay, work through it as much as you can. It's a long calculation, as you can see, and there's a lot of places to go wrong. And I'm not going to go through it all now. If there's something you don't understand about that, please email me or whatever. But another option to check, if anything, would be to put in your calculator. Okay, so here, remember, defining functions saves time. In fact, in hindsight, I would have defined these before I graphed them, so I just had to type them in once. Anyway, you can see there I've defined the first function, defined the second function. So my first integral is one minus the other, and second integral is they're swapped over. And you can see there I get the area between the two curves, which is pretty much the same as the answer we just looked at there a minute ago. Alright, this is integration by recognition. This is a pretty tricky question. It's heavy going. Notice how long it took me. I haven't got a lot of space, but I've gone through it probably in more detail than I needed to in some ways. 5 marks, so it's a biggie. Okay, so it's not an all or nothing. You know, the first thing you should do is make sure you can get the derivative. Alright? If you can't do that, marks are going to be hard to come by. But you're on 1 or 2 if you can get the derivative. And of course, because it's two functions multiplied by each other, it is the product rule. So you can see u is x and v is e to the power of 2x. Then we get to u dx and to v dx. We apply the product rule. So there's our derivative, 2x times e to the power of 2x plus e to the power of 2x. Okay, so just to go over that, it's that times that plus that times that. So pause the video here if you're a bit unsure about that. But that's how we get the derivative there. So we've seen before that once you've got the derivative, then the integral of that derivative gives you what you started with. So that's always your second step in these questions. So the integral of 2x e to the power of 2x plus e to the power of 2x is what we started with. Okay, you can link those two things together. Alright? Now, what we're after is our target integral. Alright? Here's our integral at the moment. Here's our target, here's our target over here. X e to the power of 2x. At the moment we've got 2x to the e to the power of 2x plus we've got this other e to the power of 2x hanging on. Alright, so just get rid of some of the boxes here again. Alright, so first thing to do is see that 2 there. I can get my target, just repeating, my target is this up here. I can get my target here simply by taking that 2 to the front. Alright, and already my target has come. Here it is. There it is. It's the same as what we've got up there. Now also, not only have I taken 2 out, I've separated this one integral out into 2 separate integrals. There they are. So there's a couple of steps I've done there. Now, from that step here, if I just from that step here, my whole objective now is to get this by itself. So let's go to the next slide. So the first thing in getting that by itself, well, what have I got to do first? I've actually got to integrate this. So I've integrated e to the power of 2x. It's a half e to the power of 2x. 1 over the coefficient of x, e to the same power, the power of 2x. Alright, next step, I've taken that guy there over to the other side and made it negative. Alright, so now I'm getting closer. Remember, this is my target. I've got to isolate it. So to isolate it from this step here, I've got to divide everything by 2. And you can see that I've done that on the right hand side. The right hand side has been divided by 2. and that 2 now has become 4, because when you divide something over 2 by 2, it becomes something over 4. Alright, so I've now got my taken integral, but remember that the different ones we did in class, we're actually going to find a definite integral here. Not just finding the target, but finding some values associated with it. So now, I know my integral is that there. Okay, so I'm now answering the question, which is to find the definite integral e to 0 of that. So it's just a matter of now of put my squarish brackets there. I've got my terminals over here, e to 0. I've just taken the integral down here, and then I place in. I substitute in wherever there's an x. Whenever there's an x, I've put in an e there, minus putting in a 0. Now, if I put in a 0 here, if I put in a 0 here, there, the whole thing's going to be 0, because 0 times anything over 2 is 0. So that's why you get this 0 here. There it is. All right. Anyway, I might get you to, rather than go through it in detail, I might get you some of those and see if you can work out, Mr. Square Bracket there, how I've got all that. Key step is the next one though, because if you look at e times e to the 2e, that's something we haven't dealt with much this year, but it really is an addition of indices. So it's e to the 1 times e to the power of 2e. What do we do when we multiply indices with the same base? We add them. So it becomes e to the 2e plus 1. So that is how that guy became that guy. And we get plus a quarter there because we've got a negative and a negative meeting up there. Alright, so there's the answer to the last one, and that brings me to the end of the integral calculus section from last year's exam.